Coffee begins as a raw, chaotic agricultural product. It is a chemically complex seed, extracted through turbulent fluid dynamics. The specialty coffee industry demands absolute, unyielding global consistency from this highly variable crop. Many consumers assume that the best coffee is simply the one they like. Relying on individual taste creates a critical vulnerability. If every evaluator or barista acts as a subjective consumer, quality control collapses, making it impossible to produce a consistent product across a global supply chain. Scaling a profitable coffee program depends on a rigid, observable systems architecture. This architecture is built on 3 specific pillars. At the base, sensory calibration. In the middle, thermodynamic execution. And at the top, matrix economics. High-level specialty coffee does not run on magic. It functions as a highly controlled physical and economic engine. The engine requires validated inputs. The first phase is the formal sensory evaluation of green coffee. Because human taste is inherently biased, the industry relies on intersubjectivity, the deliberate alignment of subjective individual experiences to reach a shared agreement on quality. Without this alignment, evaluation scores drift. This breaks the critical link between the producers growing the coffee and the roasters buying it. To prevent this drift, professional assessors use rigorous intercalibration protocols, working within the framework of the Specialty Coffee Association. Calibration pulls disparate sensory data into a reliable consensus, creating a tight cluster of agreement. The coffee value assessment maps these flavor attributes quantitatively. To keep data pure, analysis remains blind. Masking origin ensures expectations don't alter raw numbers. Maintaining this accuracy requires years of training, proficiency testing, and continuous statistical monitoring to catch deviations in an evaluator's performance. Sensory data is only valuable to an enterprise when it acts as an objective, uniform input for the mechanical supply chain. The calibrated sensory input determines the mechanical execution required on the bar. Every espresso shot is a mathematical function of dose, yield, and time. A standard extraction uses a 1:1.5 ratio, 20 grams of dry coffee yielding 30 grams of espresso in 30 seconds. To hit this, baristas manipulate grind size, controlling fluid resistance. Finer particles increase resistance, slowing flow. Coarser particles decrease resistance, passing water rapidly. Dialing in espresso is an exercise in applied physics. It is the manipulation of fluid resistance to hit a specific target yield. The second critical physical process operates under absolute rules, milk thermodynamics. Professional latte art requires sub-0.1 mm microfoam, depending on a structural chemical transformation. Milk protein denaturation occurs strictly between 140 and 150 degrees Fahrenheit. The chains unfold, wrapping around injected air bubbles to create a stable matrix, trapping the air. Surpassing 170 degrees physically destroys these structures, resulting in a thin liquid with a scalded flavor. Air must be incorporated during the first third of the steaming process, before the milk reaches its thermal threshold. Milk texture is dictated by these thermodynamic boundaries, overriding personal intuition. Physical execution serves the ultimate endpoint of the system, economic optimization. Hospitality's operations use the menu engineering matrix to dictate decision-making. This matrix maps every item on an x-axis of popularity against a y-axis of profit margin. Stars are profitable and popular. Their quality must be protected. Puzzles provide high profit but low popularity, requiring marketing to increase visibility. Plow horses are popular with thin margins. These require mechanical interventions, like reducing yields, mathematically balanced to not drop below the sensory baseline. Finally, dogs are unpopular and low profit. The system demands their ruthless liquidation. Menu design is a data-driven algorithm, ensuring financial survival supersedes emotional attachment to specific products. Sensory calibration, flow physics, and matrix economics are part of a single feedback loop. The economic demands of the matrix dictate the physical yield targets required at the espresso machine. Those physical yield targets then dictate the exact sensory baseline scores required from the cupping table. This data flows backward, making the entire supply chain an interdependent economic loop. The best coffee is the one that mathematically sustains this loop. Expertise in the industry requires mastering all 3 levels of this architecture simultaneously. The specialty coffee industry converts agricultural variability into repeatable consistency by engineering quality at every level of the architecture.